Cool, good morning everyone. Well, I can't really see you guys that clearly because the lights are really hard on me, but I hope everybody's going to be attentive for the rest of the day. Uh, as Android developers, we are actually not just building apps anymore, right? We are building intelligent features that are contextual, personalized, and proactive, which is not just about delighting our users, also meeting the users' expectations today. I'm Amrit Sanjeev. I'm part of the Android Developer Relations team, and I'll take the session for you today. Today, we're going to deep dive into hybrid inference and see how it's about to change how we build AI features in Android apps. We'll start with a quick overview of our Gemini model capabilities. Then we switch to Gemini and Firebase AI logic and Gemini and Firebase AI logic in production works, and some of our existing apps are using it. And lastly, we'll talk about how to get started with hybrid inference. Let's start with a quick overview of the Gemini model capabilities. So currently we have 5 main models. We have the Gemini Pro 3.1 Pro, which is our state-of-the-art model with the best reasoning, state-of-the-art reasoning right now. The 3.5 Flash, which is close to a frontier model, but is still at the fraction of a cost, so it's still better cost effectiveness. We have the 3.1 Flash Lite, which is our really cost-effective model for bulk operations and speedy inference. When it comes to image generation and editing, we have our Nano Banana models. And lastly, we have Gemini Nano, which is running on-device efficiently and is supported by our flagship devices. These models are very capable. Like if you look at it, you can use them to process image and text together. And some of the larger models running on cloud can also work with audio, video, PDFs as input. When it comes to outputs, you can actually ask for structured output like JSON, which enables you to kind of integrate it into Android apps or other programming environments. They can even call Kotlin functions within your Android application code. And lastly, when you want to generate images, we have the Nano Banana models available for you. For the past few months, we've been adding grounding capabilities to the Gemini API. So let me share that with an example. Imagine you're building a cricket assistant and using Gemini API, and you start by giving it a system instruction like you're a helpful cricket assistant and you want to ask questions to it and get responses to it. But if you ask a question about an event that happened after the training cutoff date, the model will not really know how to respond to that, right? Because it's not trained on that data. The event happened after the training data. So if a way to work around this is to provide some extra data in the model or in the context of the query, so the model can actually process that information along with your prompt so that it can answer the questions correctly. For instance, in this example, I've given grounding data as the Royal Challengers, the teams that actually played, and the scores that they got. Okay? But the question is which team won? And the response that it will give is an intelligent response, which is Royal Challengers Bangalore won by 6 runs. So it's able to use this data. It's not just directly copying answers. It's able to understand that data and give you more intelligent responses based on that. Now, you can implement grounding data yourself by passing it, but also we have given 3 APIs for it. We have URL grounding, where you can provide a URL from which data will be extracted and content will be analyzed, and that will be used to give intelligent responses. We can also provide maps grounding, where the system will use that to answer location-aware accurate responses. And third one is the web grounding, where it will actually use data from real-time web and try to reduce hallucinations and give you up-to-date answers for things. Let's see that with one example. A little bit of a code. Very little code though. We initialize our model where you are actually going to give in the tools, you actually give tools.google.maps. This is an example of maps grounding. With just that, you would be able to ask questions which are location aware, like what are the best 5 vegetarian restaurants in Bangalore? And the system will use maps data and then try and answer that question for you. Very similarly, if you want to look at web grounding, again, instead of Google Maps as a tool, you would actually provide Google Search as a tool. This would allow it to actually answer questions which will change over a period of time, but then again, things like who's the favorite team to win 2006 World Cup? this would result in it looking for the real-time data and then answering it for you. So if tomorrow the data changes to another team, if that's what the system suggests, it will actually answer correctly and then also. Now, with that, let's walk through how Gemini and Firebase AI logic is used in production, and how some of the apps are already integrating this. Now, when it comes to building AI features, one of the most challenging times is to kind of create and manage the infrastructure and create all the web wrappers and API wrappers around it, right? And this is where Firebase AI logic changes the game. It allows you to integrate Gemini models into your Android apps with zero friction, and it's really fast and with almost zero friction. Instead of routing everything yourself, you can actually trigger powerful AI tasks like summarization, translation, proofreading, all of these directly on Firebase, and Firebase will run these securely. Firebase AI logic will run this securely in cloud and lets you ship production-ready features out really quickly. So in short, this is the fastest path for you to kind of go from an idea to a production-ready AI feature in your application. Now, when we talk about Firebase AI logic, we are not talking about a prototype here, or we are not talking about a proof of concept sort of a thing. This is enterprise scale stuff. Right now, as we speak, thousands of apps are using this in production and handling millions of requests without breaking a sweat. So when I look at it includes small companies, all the way from small apps to enterprise level applications using this already and working with it seamlessly. So where the takeaway here is simple. It's not just powerful on paper. This is a battle-tested, production-ready production-ready tool that you can use and integrate with your applications today. Building AI feature is one thing, but understanding how it behaves in the real world is a completely different ballgame altogether. So without proper visibility, it's very easy to get blindsided by a high latency, high number of errors, or a massive token bill. Now, with Firebase AI monitoring, that guesswork can completely disappear. By simply enabling it in console, you can get instant app-level observability to your client-level AI traffic. What this helps you is that you can track overall costs, you can check the success rate, and capture exact prompts and responses that might be breaking down and causing and leading to failures in the system. Ultimately, this feature really helps you convert raw AI metrics into fast, reliable, and optimized user experiences. So definitely use this. If you are using Firebase AI logic, definitely turn on monitoring of API in real time. Now, another bottleneck, a major bottleneck is hard coding of prompts in your application. Now, if you hard code a prompt in your application, or the prompt templates inside your application, what happens is every time you want to make a change, you have to change your code, do the QA, then publish it in Google Play. Google Play reviews it, review process has to complete, then it's in production, and users have to update. This is a pretty lengthy process. It takes sometimes weeks for you to do that, and that's not always optimal. By removing your prompts entirely to cloud, using Firebase, specifically Firebase remote config or Firestore, we can decouple AI logic and your code. So you can update each of them simultaneously. I mean, without having any connection to each other, you will be able to update your apps, publish it, and you can at the same time update your, with different timelines, you can update your prompts also. The strategy is simple. As your app starts up, it'll fetch all the prompts on the server, use that, and execute the user's request. But this means that if you start noticing that the LLM is hallucinating, or you find a better technique which uses lesser tokens for your same requests, you can actually go ahead and update it on the server side inside Firebase, and it will be available for all instances of your app instantly. 100% of your users will get it the moment you publish that. So this is another technique that you definitely need to use. Do not hardcode your prompt templates into your app. Now let's look at how we secure the backend using Firebase App Check. Think of this app check as an extra layer of defense for your infrastructure. While we use standard authentication, which basically tells us who is accessing the resources, Firebase app check verifies where the request is coming from. So it avoids all these unauthorized traffic at the door by ensuring that only genuine, unmodified your app, can access your backend infrastructure, and that way you can actually reduce all this malicious intent requests from the system. By attesting the requests that originate only from the app, it effectively cuts off malicious bots, scraping tools, and billing abuse before it even hits, before it either impacts your database or your wallet. So it's essential that both this, it's an essential step for both protecting your users' data as well as your backend access. Now, if you want to see some of this real-world adoption happen, you look no further than some of the top apps in India. Redbus, they completely transformed their customer review system. They implemented a voice-to-text feature using Gemini Flash, where it allows users to, or travelers, which are users of their app, to kind of provide their feedback in natural language. The system transcribes it, translates it, and then adds it as a review. The user can edit if needed, and then they can publish that review. A simple change like this allowed users to communicate more easily, and that has increased a 57% increase in their customer review depth, which means there is about 57% of increase in how much review people are giving. Because with voice, you can actually give a lot more data than just provide it on text, right? Like typing on a smaller keyboard. So let's hear what they have to say.
By empowering our Android team with Gemini Flash using Firebase AI logic, we saw an incredible 57% increase in review length and captured richer, better user reviews in just a month.
Ready?
Hi, I am Abhi Muktishwarar, Senior Tech Lead in Mobile Engineering at Redbus.
I am Gajendran, Senior Engineering Manager in Mobile Engineering at Redbus.
Redbus is the world's largest online bus ticketing platform. We connect millions of travelers globally, and over 90% of all our bookings are through our mobile app. Reliable user reviews are critical. While our existing text-based system served us well, that lacked the necessary detail and volume we needed to deliver maximum value to both travelers and operators.
We saw a growing user preferences in India for voice communication. Our goal was to let users speak their feedback in their native languages. Using Gemini Flash through Firebase AI logic was the key to unlocking this. It allows us to improve the volume and quality of reviews dramatically. As a mobile team, the ability to rapidly test this idea was crucial. The integration of the Firebase AI Logic SDK into our app removed the need for backend engineering resources and let us work independently, allowing us to go from idea to launch-ready feature in just 30 days.
The UI encourages users with a prominent mic button and a prompt. The user speaks in their native language. This is where Gemini's multi-language and multimodal capabilities shine, supporting everything from English to Tamil, Hindi, and Telugu, enabling a fully localized experience.
And a driver romba speed outnar. Overall, nice experience.
The voice is recorded and sent to Gemini Flash. Within seconds, the model returns a valid JSON object that includes the accurate transcription, the translation into English for our systems. Will do a sentiment analysis to determine the rating, selecting the relevant tags, and a profanity check. We parse the JSON to instantly autofill the entire review form. The user simply reviews the AI-generated text for accuracy and submits. By eliminating the need to type, we got richer, more detailed data in return. The migration from Gemini 2.0 to Gemini 2.5 was smooth and easy. The increased performance was noticeable with minimal code changes required. My key advice for other developers: AI is for everyone. The Firebase AI logic removes the need to be an ML expert, and the ease of integration enables us to quickly prototype on Android and get early valuable feedback.
The launch of the new AI-powered user review experience is a win-win-win for our traveler, for our operator, and for our development velocity.
next one I want to talk about is Gratitude, which is a mindfulness app that uses affirmations to help a user align to their own core values and boost confidence. So affirmations, if you don't know, is basically are positive and intentional phrases that are used to battle negative self-talk and revive your subconscious thinking. So Gratitude actually built a very interesting feature. They built a a mood-aware affirmations curator, which uses, the use case is basically that it uses AI to detect the mood of the user based on the journal entry they have done. So if you're sad or you're feeling depressed, it actually would then finish, as you finish your journal entry, it starts surfacing up empathetic and affirmations that uplift your mood. So based on your mood and how you're actually journaling, your curated affirmations actually changes based on that. A very popular feature among the users today. And finally, a health pioneer, Ultrahuman, who used AI to tackle an issue of cumbersome data entry. Very simple use case. People don't want to write in a lot of data as they are logging in food use case. And they saw that this feature has a high abandonment rate because there's a lot of entry that needs to be done. So how they've changed it is that you take a picture, send it using Firebase AI logic. What they've done is they built a feature which actually takes a picture of the food that you're actually taking, and it actually approximately calculates the caloric value of the food and making the whole food logging experience simpler. And with that, they've actually seen a 50% improvement in the number of people who are consistently using this feature. So even a small change like this can actually make a big difference in the amount of data that is gathered from the user and the information that you are useful information that's being provided to the user directly. Now, the takeaway here is very simple. You probably have a use case that you want to actually build in your application using AI, and Firebase AI Logic could be a perfect match for implementing that really quickly for you. And with that, let's talk about hybrid inference. Earlier, I talked about Gemini Nano running on some Android devices. But if you want to combine, what if you want to combine both on-device and on-cloud inference together? And that's a promise of hybrid inference. Let's see how we can leverage both on-device and cloud inference capabilities with Firebase AI Logic Hybrid Inference API. So starting, you basically have to add the on-device dependency also along with the Firebase AI dependency, AI Logic dependency. That's the first one. You integrate the SDK. The second one, the code part is straightforward. Once as you are actually initializing your model, in the on-device config, you provide a mode called inference prefer on-device. Now, there are 4 supporting modes actually. There's prefer on-device, there's prefer on-cloud, there is only on-device and only on-cloud. I'm not explaining it because they're self-explanatory, right? Like you know what happens when you give each one of them. But, and if you want to apply this is available today. All the documentation is there. You can go ahead and clearly look at our documentation, look at our sample code implementation. That will allow you to implement it straight into your app. But, and if you look at it, the routing logic that we used was very simple. It was simply looking at whether simply on Gemini Nano's availability or network status, network connectivity, and then routed it to the appropriate ones, right? But what if you need something which is more sophisticated? For example, you might want to switch to on-device, you might want to switch to cloud when the device's CPU is overloaded or your battery is low. In the same way, you might want to switch to on-device when network connectivity is flaky. And these are not standard conditions, right? So let's look at, or it might be even as simple, simple as you want to use a model to decide based on the complexity of your query, whether it should be done on-device or you want to route it to on-cloud. So based on your use case, there are multiple strategies that you can apply in order to kind of decide where to route the query to. It could even be chained, where part of the work happens on the device and the rest of it happens on the cloud. So these multiple strategies are available. It's not just one or the other. You could use both. But let's go through an example to see how we can actually, how some of this can be decided. And it's totally up to you as an engineer to decide how this logic should be built. Let's take a concrete example. We'll have a hypothetical app called Sparkle Mail, which is just an email app, which is kind of an imaginary one. We just have the mock for it now. It is basically, it was also boosted with a few AI features. We want to proofread, we want to provide proofreading, rephrase, and formalize. Proofread is basically you correct the grammar. So if somebody user has typed in something, you can able to search view through that, so correct the grammar, spelling mistakes, all of those aspects. Rephrases, maybe change the sentences to make it look more polished. And formalize it is to use words which make it sound more formal and professional. So these are 3 features that we want to have for the user. But we also want to support Indic languages, especially Hindi, Kannada, Marathi, Telugu, Urdu, Bengali, and Tamil. So that is another requirement of this app. And more specifically, you have to have all those features that we talked about work with all these languages, not just English. So proofreading is not just proofreading, rephrasing, and formalizing is not just features that we want only English typing users to have, we want them to have it for all these languages also. So, and last requirement, we want to lower the inference cost. This is going to be used by millions of users, assume. So we want to lower the inference cost. So we want to do it on device as much as possible. But let's see how we can do this. So if Gemini Nano is available, we would prefer that to be used whenever possible. And when otherwise, when Nano is not capable, you want to kind of shift to the Flash model. But what does capability really mean here? And that's the real question for the app developer. Well, if you ask Gemini Nano with Hindi text like this, which is party kahan, and then ask it to do this on device and formalize this, it is actually giving a pretty decent response to it. So you can actually use this pretty well. It works pretty well, and you can use for Hindi, you can use for the formalized feature, on-device feature is good enough for it. But if you give something in Kannada and you're actually asking it to proofread, you're not getting response, say for something like Party Early Day, your responses is not exactly what you expected it to be. So maybe you need the Flash model on cloud running it because Nano is not able to correctly recognize or correct the spelling mistakes in this case. So now if you look at the jeopardy here is one language, a couple of languages are supported by, a couple of languages are working very well for your use case locally, but some of them are not. That's where you have this custom logic that you really need to start working with. So this is basically the proofreading example. And that is where you want to kind of now decide based on the language you want to now route the request to the right place, right? That's where we will use the MLKit language identification API. This is running on device. So if you pass a string to it, it basically, if you pass a string on like this, like Patika, and you give it to the MLKit language, it will actually identify it with SHI. That's not high, that's HI for Hindi. And if you give a Kannada string, it will actually give you KN. So based on this mapping, you can understand what language the user is actually typing it in. Then you can, when you instantiate the model, you can instantiate this model, and this is the code for it. So basically, you instantiate the model, you ask it, the function call is identify possible languages. You attach a success listener to it. It gets a list of languages along with a confidence score for it. Based on that, you can decide which language it is. Take the language identifier and then map it to a language and decide how to route your query. That's basically the thing. So in this case, how we would actually finally develop this is where English, Bengali, and Hindi would go to Nano. Kannada, Marathi, Telugu, Urdu, and Tamil would actually go to Flash. That is basically the routing logic based on capability that we found while testing it. So this is a custom logic, right? And that is something that you want to actually, that the idea here is every use case you will need to test similarly with a set of test cases, identify the capability of Nano or Flash, where would it be the best place to kind of do it, and then route it accordingly. Many times this logic is custom. It is not based on connectivity, it is not based on availability of on-device models or connectivity status. It has to be something custom like this to be most effective. And now that we have understood this possible languages, we will use Gemini Nano whenever it is in this app. We will use Gemini Nano whenever we type in Hindi or when we type in a language which it can support with the on-device model. We will automatically switch to that. or we will send it to the cloud and get the result from there. The whole idea is the experience for the user should be the best. So okay, that's what we are aiming for. We are not trying to prove one is better than the other, or one's capability should be compared to the other. That's not the point. From a user's perspective, when I'm using this app, whether I'm using Hindi or English or a different language, my experience remains the same. I can use all these AI features very well. Like again, just to give other examples that we have, Gboard is another one which is using on-device models with hybrid inference, which is one of our 1P apps, which uses it very well. And this is some of the you might already be using some of these features, and if you haven't realized it, it's already running hybrid inference for this. So on devices where it's capable of running on device, it's actually using on-device models to give you answers. And where those models are not available, it's actually going to the server and coming back. Another example is pixel screenshots. This is another one of our apps which allows you to kind of do semantic search on screenshots that you have actually saved on the device, right? So a key takeaway from all of this session is basically that there's no one-size-fits-all sort of a solution. You don't want to use only cloud or only device. Depending on your use case, things will actually change. You need to kind of, it's like a balancing act. You need to kind of balance cost versus accuracy. So there are multiple ways in which you have to route it. So hybrid inference could be one option that you have. There are different models that we have capability. Like I mentioned, there are different capabilities of different models. That is another thing that you have to consider. Depending on the cost factor, depending on the latency, depending on the accuracy that you need, you might want to go from a Pro to a Flash to a Flashlight, and you have to make those choices yourself. And lastly, there might be instances where you can do partial work on the device and the rest on the cloud. That is also an option for you architecturally, where if there's on-device model available, you do part of the work here, and then you can actually chain that and take the output of that and pass it to the cloud and get things done there. So with that, I would end the session. This is a short one, but I would really hope that most of you guys would go out and try Firebase AI Logic, because the amount of code that you need to write in order to implement this is really short. Like 5-6 lines of code, maybe 15 lines of code is all that it takes for you to test things. So this is great for prototyping, and you should definitely try this out.